lunch because they are superfluxes. Great, we have seen how to explore and examine the correlation analysis. Problem statement. You are a public school administrator. Some schools in your state of Tennessee are performing below average academically. Your superintendent seems to be under pressure from frustrated parents, and the voters have approached you with the task of finding out why these schools are underperforming. Now, to improve school performance, you need to learn more about these schools and their students. Just as a business needs to understand its own strengths and weaknesses and its customers. The data includes various demographics, the school faculty, and income variables. This can be achieved using exploratory data analysis techniques, which further includes reading the data in Pandas data frame, describing the data to find more details, finding the correlation between reduced_lunch and school_rating. Let's start with importing the necessary libraries and the corresponding CSV file. Also, you can use the describe function to statistically explore each of the variables. Now that you have obtained the basic statistics for all of the attributes and are interested in only the reduced lunch and school rating variables, you can extract the two variables directly and group one with respect to another so as to get the data distribution of the former with respect to the latter. Also, you will use the unstack function here to represent the data in a different way. With this function, your columns will be your rows. Now, you are supposed to find the correlation between the two extracted variables, so you can use the correlation function for the same. This gives you a correlation matrix where reduced lunch is 100% correlated with itself. Every variable is 100% correlated with itself. Also, the correlation between reduced lunch and school rating will be the same as school rating and reduced lunch because they are superfluxes. Great, we have seen how to explore and examine the correlation between variables. Let's quickly recap the steps we have covered so far. Import libraries and the data set. Examine the statistic of each variable. Extract the relevant variables. Examine the correlation between relevant variables. Data wrangling is the method of changing and mapping data from its raw type to a different format with the aim of making it more valuable and acceptable for advanced tasks such as data analytics and machine learning. It includes munging and data visualization. Different tasks in data wrangling are: 1. Discovering which includes undercover or extracting features from given data. 2. Structuring, which includes mapping the extracted features to the actual feature set. 3. Cleaning, which includes refining of data in order to make it more accurate. 4. Enrichment, which is the addition of features or data in order to make the given data more detailed and informative. 5. Validating, which defines whether the data is valid to be used or it has some missing or wrong information. Data wrangling helps us avoid the following issues: missing data, which is a common issue with raw data sets, presence of noisy data and outliers, which makes the data set heavy and complex, inconsistent data, which makes it difficult to identify usable data out of all of the data present in a data set. It helps you create an accurate model or prediction out of data. Data wrangling also prevents data leakage by ensuring that data is secure and accurate. Missing values in a data set. Look at the given random data set. You can see that there are some places where the data is missing. Missing data can be in the form of blank field or null value, also denoted as NaN. In most of the cases when the data is available, it is not inserted into a data set and the field is left blank. This occurs when there is a raw data set that has irrelevant fields within it. There will be situations where your data set has some missing values, and you want to find out the columns that have the missing values. Now, in order to detect the missing data, use the following code. df1.isna (.any) with the data field to get a list of columns that have missing data. This will give you the column name as output. If a column has any data missing, it will be marked as true, else it will be marked as false. Now that you have learned how to find the missing data in a data set, you may also want to replace missing data with other data. There are a few imputations you can do for the missing data, such as mean or median imputation. Mean imputation in placing of missing values. If you want to impute the variable's mean in place of the missing value, use the code given on your screen to do so. This can be done by importing the imputer function from scikit-learn library. Similarly, if you want to impute the median value in place of the missing values, use imputer function of scikit-learn library to do so. Remember, mean-median imputation is model-dependent and is applicable only on numerical data. Outlier values in a data set. What is an outlier in a data set? An outlier is a value that lies outside the usual observation of values. This happens when one or more data in a data set has exceptional value which varies from the rest of the average values of the observation. These values skew the data when you are trying to calculate the average of the whole data, as the values vary a lot from the usual observation. How can you detect an outlier? In order to detect an outlier, you need to use Seaborn Library. Use the following code to detect an outlier in the form of a pictorial representation. Import Seaborn as SNS. SNS.boxplot parenthesis x equals df1 bracket apostrophe assignment apostrophe bracket parenthesis. As you can see in the graph given, the usual observation values lie within 80 to 90, whereas there are a few data values less than 60. Here, the data that have a value less than 60 are the outliers. How can you remove these outliers? You can remove the outlier values from the dataset using the given code. You first need to create a filter which will have all the outlier values and will be a differentiator between outlier values and usual observation. The filter is then assigned to an object. You can then remove the object in order to remove the outlier values. As shown in the output field, all the values under column assignment filter filtration lie within specific range. Demo outlier